Welcome. This video is over how to order rational numbers again. So let's look at our number routine. Sybil fed different cups of food to her cat. Arrange the amounts from greatest to least. So we have 3/4, 7/12, 2/3, 5/6, 1/2. How do you would like to do this? Would you like to estimate? Would you like to turn these into decimals, or would you like to find a common denominator? Well, first of all, I'm going to maybe estimate. Well, I know half goes here in the middle. This is a little more than half. Actually, they're all more than half. So, yeah, because half of 4 is 2. So, half of 12 is 6. So, this is barely more than half. Ooh, whoops. This is more than half. This is like half of 6 is 3. So, this is like way more than half. So, you know what? To make it a little more precise, I am now going to use common denominators. What does 2, 12, 3, 4, 6 all share in common? Let's think. 2, 4, 6, 8, 10, 12. Do you remember least common multiple from elementary school? 12, 3, 6, 9, 12, 4, 8, 12, 6. They all share 12 in common. So let's make a common denominator of 12. How many groups of 2 go into 12? 6 times. So that's 6/12. How many groups of 3 goes into 12? 4 times. So that's 8/12. How many 4s go in 12? Times 3 times 3, 9/12. How many groups of 6 goes in 12? 2 times. That's 10/12. So now, God, our estimating ability is pretty good. 6/12, 7/12, 8/12, 9/12, 10/12. They are now. Oh, wait. I didn't even read the direction. I am so embarrassed. It said put it from greatest to least. So I mean, how embarrassing. 10/12 or 5/6, 9/12 or 3/4, 2/3 or 8/12, 7/12, and then 1/2, which is 6/12. Now it's from greatest to least. I am embarrassed. I didn't even read it. So make sure, that's a note to yourself, least to greatest or greatest to least, depending on the question. So what we're going to do today is you're going to be trying to figure out where are these numbers on the number line. So you know what? I'm going to cover all of them right now. And now I'm going to try to estimate where they are. Let's get my pen out. Calligraphy pen. Where would you find 7/4? Do you remember how to turn an improper to mixed? If you forgot, you divide 7 divided 4. Can 4 go in 7? 1 time. What do you have left over? 3. How can y'all write that 3 in fraction form? 1 and 3. What's the denominator? 4. So 1 and 3/4 is more than 1 but less than 2. So it goes somewhere right here, 7/4. 5/2. Do you know how to write a mixed number? How many 2's go in 5? 2 times. Our remainder is 1. How can I write this in fraction form? 1. What's the denominator? 2. 2.5. So that's more than 2. Halfway right here. So it's 5/2. What's the absolute value of -3? How far is -3 from 0? 3 units. So it goes right here. Absolute value of -3. Can you think of a rational number? It could be a fraction, decimal, whole number, integer, counting number, anything less than -4. So again, a number line goes from least, the negative numbers are where you find the least numbers, while the positive number find the greatest number. So less than -4. That'd be, I'll say -5. Find an integer less than -1. Let's say -2. And ooh, this is a little harder. So it's -10/3. So can 3 go into 10? 3 times. You have a remainder of 1. How can I write this in fraction form? 1/3. So it says -3 and 1/3. So I count backward. -1, -2, -3, and there's some more stuff. So it goes somewhere right here. -3 and 1/3. And that's how I can copy and completed this number line. So what you're going to be doing now is we're going to be doing something called clothesline pin. So you're going to be having like a clothesline, and you're going to try to estimate where it goes on a clothesline. So in this one, I'm going to put 0 in the center for this. I can use my finger to do this. 0 right here. 1 goes here. Wait, this is more than 1, so I guess that will go at the end. And the rest is the thing. So, I'll put 0 right here because I see no negative. These are all positive. So half must be halfway between 0 and 1. Hmm. If isn't half the same thing as 50 cents or 5/10? It is. 75. Is that more than 50? Yep, it goes somewhere right here. And then 1/3, 1/4. If I have 4 parts, 1/4, less than half, it goes right here. So where would it go here? 1/3, 1/4. Let's see. If I have 4 parts and I cut up one of them, I think that's going to be less than if I had 3 parts at one. Think of a pie. If you have a pie, I'm going to draw a picture. You draw a picture if you need to. So 1/4, 1/3. 1/4 is less than 1/3. Then 5 halves. How many 2's go in 5? 2. We have 1 left, 2.5. So that must be the greatest of them all. And that would go right here at the end. Let's try another example. 0. I see all positive numbers, so I don't need it. I'm going to put 0 at the end. 1. Half goes in the middle. And next one. Half is like, if I have a half of a dollar, that's like 50 cents. So 85 cents must be more. 65 cents must be more. Next one. 7/10. 7/10. That is like, highlighter, 10. 7/10. I'm going to build this to hundreds. So if I build that to 100 times 10, that'd be 70 hundreds. So that'd be, I want to build all these into hundreds. Can 20 go into 100 times 5? That's 65 hundredths. This is 70 hundredths. 4/5, I could do tenths or hundreds. I'm going to do hundreds times 20. That's 80 hundredths. 3/4 of a dollar. If I have 4 quarters, 3/4 is like 75, I believe. How do you turn a 4 to 100 times 25? That's 75 hundredths. So let's move these. So this is like 70. Oh, these two are the same, 65. This is like 80, and this is like 75. And that's my answer. And our last example, we have 0. We have 1. Oh, I see negatives. So let's put negatives right here on the left. Let's do all the positive first. Positive, positive, positive. Well, uh, 1/3, I go right here. That's closer to 0. Is this more than half or less than half? What's half of 6? 3/6. So it's more than half, so it goes closer to 1. And 0.33. Did you know 1/3 is the same thing as this? In case you forgot this from mathematics, let's show you why. Here's 1/3. It's 1 divided into 3 parts. Can 3 go in 1? 0 times. Annex a 0, because it's, then can 3 go in 10? 3 times. 1. Annex a 0, bring it down. Can 3 go to 10? 3 times. I believe this is going to be a repeating, and it does repeat. All right, and 3 halves. Is this more than 1 whole? This is improper, so it has to be more than 1. That's, if you would like to know, that's 1.5 or 1.5. Now we have 2 negative numbers. So 0. Let's see, is negative 1/2, let's think about it. If negative 1/2 goes right here, is this more than negative 1/2 or less? Is it closer to 0 or closer to negative 1? This is like barely, so this is barely a negative, so it might be closer right here. And this is more than a half, so it's closer to 1 whole. Another way to do it is find a common denominator, if that makes it more easier for you. So what does 3 and 6 share in common? 6. How do you turn a 3 to a 6? Times 2 times this. So negative 4 6 is farther away, is more from 0 than negative 1 6. And that is our lesson. The last thing you're going to do is you're going to try to estimate where these go on here. So let's estimate. These are all, this is positive. So let's put all the negatives down here and the positives here. So positive, let's see. If this is the halfway point, it can't be 75. Oh, must we go right here? Again, this is more than half. And let's see. These two look very similar. 3/8 and 1/3 does look very similar, so I'll let you put in either one. Because if you do a common denominator of it, they're actually really, really close to each other. What does 8 and 3 share in common? 24ths. 8 times 3 is 9/24. 3 times 8 times 8, 8/24. So 3/8 is 1/24 bigger than 1/3. Next one, negatives. Let's see. This one looks like is right in between, halfway between 0 and, oh, so it's this one. And last but not least, which one would it be? This one looks closer to -1 than this one. So let's find a common denominator here. What is a common denominator between 5 and 3? 15. 15. That's times 3 times 3, that's -9. Times 5 times 5, that's -10. So who is farther away from 0? -9 or -10? -10. So this one will go here, and this one will go here. So -10 goes here, and -915 goes for this one right here. All right, so that is our lesson over ordering rational numbers. Try to find common denominator. I did a lot of estimating. Estimating is probably the best way of doing this.